So students, we were discussing basically the factors that affect runoff. We had already discussed about quantity estimation for sewage. I told you that the total amount of water supplied in any area, 80%, as a thumb rule we take 80% of that water turns into wastewater, right? So basically, if you want to assess or if you want to measure the quantity of sewage that is going to be generated in any area, you should have an idea about the population that is getting the water supply and what is the per capita requirement of water. Okay, then we will multiply that population that is being served with the per capita water demand, and we will get the total amount of water supplied. 80% of that water is going to be turning into wastewater. So multiply 0.80 for 80% of that water. That will be basically the quantity of sewage being generated. Now, how to estimate the quantity of drainage, storm water that is going to be generated in any area? So for that, there are several factors, because when you want to know what is the quantity of drainage going to be generated, we should have a clear idea about the precipitation, and for that we need to see the precipitation data over 35 years. Then only we can declare, okay, this is the precipitation in any area. So in order to determine the volume of runoff, there are several factors that affect. Coefficient of runoff is there, intensity of rainfall is there. I told you that the intensity of rainfall is a very vital factor. If it rains very heavily for 15 minutes, that will affect and that will generate more runoff with respect to if it rains for 2 hours at a very, very low intensity. Am I right or wrong? For 2 hours if it rains and the intensity is very low, that will generate very less amount of runoff with respect to heavy rainfall with high intensity for 15 minutes, for 20 minutes. So intensity of rainfall is an important factor. Then, you know, when rainfall touches the surface of earth, every area that receives rainfall can be termed as a catchment area. I have told that Durgapur is a catchment area. Okay, or any area which receives rainfall, it can be a city, it can be a town, it can be a larger district. You can term it as a larger catchment with smaller catchment areas. Okay, so the point where water hits the surface of earth, okay, that is the inlet time. Then it takes time to concentrate, it takes time to accumulate water from all the portions of the catchment. That is termed as time of concentration. The period after which the entire catchment area will start contributing to the runoff is known as time of concentration. And the rainfall which with duration lesser than time of concentration will not produce maximum discharge. So basically, if the time of concentration is less, okay, if surface duration of rainfall does not matches with the time of concentration, time of concentration can be a minimum time after which entire catchment area will start contributing runoff. Okay, so if the rainfall duration is suppose 15 minutes, 15 minutes, and the time of concentration is suppose 30 minutes, 30. That means it's lagging by 15 minutes more. Okay, so time of concentration is not reached, and hence rainfall with that smaller duration will not contribute that much amount of runoff. इसका मतलब कि runoff तभी time of concentration को जब reach कर जाएगा that duration के लिए अगर rainfall होगा, then only that requisite runoff will be generated. The runoff may not be maximum even when the duration of the rain is more than the time of concentration. This is because in such cases the intensity of rain reduces with increase in its duration. You must have noticed when it rains at the beginning, suppose it is raining heavily, then it slows down, the pace slows down, intensity decreases with time. This is a diagram which shows the inlet time, Ti, the time, the point at which the rainwater meets the surface, then time of concentration is shown, and the maximum runoff will only be obtained from the rain having a duration equal to time of concentration. It can be asked in MCQ also. when time of concentration and rainfall duration match, then only maximum runoff will be generated. If time of concentration is suppose 20 minutes and rainfall occurs for 10 minutes, then runoff will not be maximum. It will be a normal runoff, where normal rainfall with very less runoff that being generated. The time of concentration is equal to sum of inlet and time of arrival. The time of concentration can be expressed as inlet time is Ti plus the time of travel, Tt. Time of travel basically is the time taken by rainfall or runoff, part of the runoff to reach either the path in the drainage, okay, or path in the catchment area. There are certain formulas for obtaining this Ti and Tt, time of travel, inlet time. This is the formula for inlet time, Ti. You need not remember this formula, okay. आपको ये याद रखने की जरूरत नहीं है. Just the theory is inlet time is expressed like this and time of travel is expressed like this. Length of the drain divided by velocity. You know, speed is equal to distance by time. So distance equals to, or time of travel we want to find. So time equals to distance by speed. That is given. Length of the drain or length of the catchment divided by velocity of flow of runoff. Okay, either in the catchment or in case of drainage, in the drainage. And just you add up the inlet time Ti and the time of concentration, you will get time of travel, you will get the time of concentration. Ti plus Tt, you will get time of concentration TOC. Now most important factor which affects runoff, amount of runoff that is going to be generated, runoff coefficient. The total precipitation falling on any area is dispersed. You know, I have also described when you must have studied in hydrology, when rainfall occurs, a part of it percolates inside the ground and reaches the groundwater table. That is known as infiltration. Another part is intercepted by buildings, structures, vegetation and all. Right? That is blocked by that and it evaporates gradually. And the last part is the runoff. After having subtracted all the things which are going to reduce the volume, that part which runs on the surface of earth and which is supposed to run into the drainage, that is known as runoff. Okay. So precipitation minus interception minus infiltration into the ground is equal to the runoff. So that has got a coefficient. The runoff coefficient can be defined as a fraction which is multiplied with the quantity of total rainfall to determine the quantity of rainwater which will reach the area. So we will not go much into the theory. You have studied this in hydrology. Runoff coefficient can be represented by this symbol K, and it can be expressed by this expression A1 K1 plus A2 K2 plus A3 K3, like that AN KN divided by A1 plus A2 plus A3 up to AN. That means product of area of that part of the catchment, okay, where the runoff travels, and coefficient of runoff for that part of the catchment. Suppose A1 is the area, a smaller fragment of the catchment, and K1 is the runoff coefficient for that. Similarly, A2 is another area, and K2 is the runoff coefficient for that catchment, that part of the catchment. So all these multiplications A1 K1, A2 K2 plus A3 K3 like that, divided by A1 plus A2 plus A3 up to AN. If you add all the smaller fragments of the catchment, you will get the larger catchment area only. Suppose this is a larger area. I divide it into many small sub areas A1, A2, A3 like this. Okay, every fragment I divide. When I add all the fragment areas, I will get the larger area. That means what? A1 plus A2 plus A3 up to AN, it is going to give actually capital A, which is the area of the catchment. Okay, where A1, A2, A3 are the types of areas with K1, K2, K3 are their runoff coefficients. The typical runoff coefficients for different ground cover is provided below. So, for watertight roof surfaces, the coefficient of runoff is going to be 0.7 to 0.95. For asphalt pavement, bituminous pavement, okay, 0.85 to 0.9. For water-bound macadam roads, in transportation you must have studied water-bound macadam, where bitumen you have not studied, you will study. Water-bound macadam are such roads which does not contain bitumen or any concrete as top layer. Okay, only water is mixed with other ingredients of the road. Okay, and leveled with the road roller. Okay, so means a pavement which does not contain either a top layer with bitumen or concrete. That is termed as water-bound macadam. Water, dust, and suppose mudam and other things are used as the top layer. No bitumen top layer is there. No concrete top layer is there. Basically, pavement आप देखना flexible pavement, rigid pavement. Flexible pavement bitumen is used, and rigid pavement will be basically a concrete surface, RCC surface, suppose a concrete surface. Okay, but in water-bound macadam, the top layer is not bitumen and neither concrete. Okay, it is basically mixture of water, dust, mudam and other such aggregates. अच्छे से mix करके and road roller चला के layer by layer it is prepared. Many times in village areas, okay, you will see that kind of road. In rural areas, you will get that kind of road.
So वो तो rainy season में फिर affect करेगा?
No, it doesn't affect generally because it is compacted in such a way with road roller and all that no groups or anything means it's not porous. There is no place for water to enter. But definitely, if we cover the top layer with binder, bitumen, or if we prepare the top layer with rigid pavement, that is much better. That is much preferable because longevity will be more. Okay? Either bitumen top or concrete top will last longer with respect to water-bound macadam for any such local roads. Then parks, playgrounds, lawns, they have coefficient of runoff 0.05 to 0.25. And unpaved streets and vacant land means the streets where there is no road. Okay, local streets, no roads, local grounds, they have the lowest coefficient of runoff 0.1 to 0.3. Parks, playgrounds, you will notice one thing, all the structured surface means bituminous pavement or suppose a rigid pavement, they have got a higher runoff coefficient with respect to playgrounds, parks where there is no such road, where there is grass layer or normal ground conditions, right? So there the coefficient of runoff is less. Why? Because there are obstructions. The rainwater, when it will flow through road surface or through a paved surface, it will flow with higher velocity. With respect to in a normal ground, muddy ground or ground covered with grasses and all, the speed will be not that much. There will be hindrance, right? That is why the coefficient of runoff is less. Means lesser the speed, lesser will be the coefficient of runoff. Because runoff is going on. Okay, water is flowing. With slower pace it is able to flow. Coefficient of runoff definitely वहाँ पर कम होगा. Okay. That means if you want to increase the coefficient of runoff, we should be aiming towards that top. Okay. Runoff coefficient बढ़ाने के लिए. The values of K can be taken as equal to 0.9 for paved areas and 0.15 for lawns and gardens. Means paved areas where there is road, unpaved areas where there is no road, no top finishing, nothing. Okay. Paved areas के लिए 0.9 has been recommended and unpaved areas के लिए 0.15 has been recommended. Now, how to determine basically what is the quantity of drainage that is going to be generated? Just like we determine the quantity of sewage that is to be generated, the quantity of drainage, how can we determine? We can determine by two methods, rational method, empirical method. Okay, you know there is a restriction, means where we will use rational method, where we will use empirical method that we will see, and also very small formulas are there that we will use to find out the quantity of drainage generated. So rational method for peak drainage discharge. Storm water quantity can be estimated by rational method. It's very important. आप इससे numerical expect करो. You definitely will get a numerical in your semester from this. So storm water quantity estimation, UP, which is the peak rate of storm water runoff meter cube per second. इसको हम Qmax से भी लिखते हैं, meter cube per second. Okay. It is equal to K into IC into A divided by 360. Where K is the coefficient of runoff that we discussed in the previous slides. IC is the rainfall intensity of rainfall. IC basically is the critical rainfall intensity. What is this critical rainfall intensity? The rainfall intensity during the critical rainfall duration equal to time of concentration. We have studied, students, that time of concentration, when the rainfall duration matches the time of concentration, runoff is maximum. ये हमने पढ़ा है ना कि जब rainfall duration इतने समय के लिए हो, बारिश इतने समय के लिए हो, that it matches the time of concentration, we will get maximum discharge of runoff. Clear? So for that duration of rainfall, okay, the rainfall intensity is basically critical rainfall intensity. Clear है? Critical rainfall intensity is that intensity of rainfall for which the time duration of rainfall matches the time of concentration. यानी maximum runoff हमें चाहिए, उसके लिए runoff the time duration of rainfall should be equal to time of concentration. ठीक है ना? So when it matches, that rainfall intensity is known as critical rainfall intensity. A is the area of drainage in hectares. So K is the coefficient of runoff, IC is the critical rainfall intensity, A is the area of the catchment in hectares. Please note this. 1 hectare is, I think 10 to 4 meters square like that. ठीक है ना? 1 hectare is like that. So area in hectares. So if the area is in meter square or kilometer, you have to convert it into hectares. If the area is in hectares only, so you need not convert. So one more thing. Somewhere you will see formula like this. UP is equal to K into IC into A divided by 36. You will also see this. So basically it depends rainfall intensity whether it's in millimeter per hour or centimeter per hour. Okay. Suppose IC is in millimeter per hour. The unit of rainfall intensity is millimeter per hour or centimeter per hour. आप देखना क्वेश्चन में स्टूडेंट्स, दिस इज अ ट्रिक. क्वेश्चन में रेनफॉल इंटेंसिटी इज गिवन सपोज इन मिलीमीटर पर आवर. सो मिलीमीटर कैन बी कन्वर्टेड इनटू सेंटीमीटर. हाउ? मिलीमीटर सेंटीमीटर में कैसे कन्वर्ट करता है? डिवाइड बाय 10, राइट? सो इफ द रेनफॉल इंटेंसिटी इज गिवन इन मिलीमीटर, ओके, देन यू डिवाइड बाय 10. डिवाइड बाय 10 मींस यहां पे 10 इनटू हो जाएगा. क्लियर? That means if I am using KC, K into IC into A by 360, that means rainfall intensity must be in millimeter per hour. और rainfall intensity अगर centimeter per hour में, then A into IC into A by 36 होगा. Clear? Students क्या करते हैं? Question में trick दे दिया गया है that IC is given in suppose centimeter per hour. Student ने use कर लिया ये formula, mistake हो गया. Clear? Now one more rational method can also be expressed as 0.278 K into IC into A. Okay, here there is no division. 0.278 K into IC into A. When this formula can be used? When A is in kilometer square. तो आपको ये फॉर्मूला याद नहीं करना है. If it is in kilometer square, आप कन्वर्ट कर लो हेक्टेयर्स में, then you can use. आपको अगर आप एक्स्ट्रा ऑर्डिनरी आपको दोनों याद रखता है तो आप दोनों फॉर्मूला याद रखिए. बट ए हियर इट कैन बी किलोमीटर स्क्वायर, देन ओनली वी कैन यूज दिस फॉर्मूला. ओके. नाउ मोस्ट इंपॉर्टेंट थिंग, व्हेन वी विल यूज रैशनल फॉर्मूला और रैशनल मेथड, वी विल यूज रैशनल मेथड फॉर स्मॉलर एरियाज अप टू 50 हेक्टेयर्स. प्लीज डू रिमेंबर स्टूडेंट्स, रैशनल फॉर्मूला कैन only be used if the area of catchment is up to 50 hectares. HA. Okay, 50 hectares. That means in the question it is given the catchment area is 300 hectares. Should we use rational formula? No. Why? Because rational formula is limited for areas up to 50 hectares. So you should be able to judge whether I should use rational method or empirical method. There is one more method we are going to discuss quickly. If the area is in 50 up to 50 hectares, we will use rational method without any problem. Okay. And if the area is more than 50 hectares, we will avoid rational method because rational method does not hold good for that area which exceeds 50 hectares. तो क्वेश्चन में आपको दे दिया 100 हेक्टेयर, आप एकदम बिल्कुल फ्लो में यूज कर लिया रैशनल मेथड और कॉन्फिडेंट हो गए, नो योर आंसर इज रॉन्ग, इनकरेक्ट, you will get 0 or step marking you might get, depends upon the examiner who is checking the copy. ठीक है. Empirical formula. Empirical formulas hold good for areas greater than 50 hectares. Below 50 hectares आप rational method use करेंगे. Above 50 hectares you will use empirical formulas. Empirical formulas are used for when we say empirical, that means what? That means some experiments have been conducted, okay, and then that formula has been derived. Empirically determined, that means after several experiments, several rounds of experiments, that formula has been framed. Okay. So various empirical relationships are developed based on past observations of specific site conditions suiting a particular region. Yes.
Above 400 hectares.
Yes, it is saying empirical formulas are used for determination of runoff from very large catchment areas, say above 400 hectares or so. Means it is indicating very large areas, but if the area is more than 50, we will avoid rational method. We can use empirical formula. Okay. This 400 indicates the larger area, but necessarily not that 400 is there, then only we will use empirical. If it is beyond 50 hectares, we will avoid rational method, we will use empirical formula. Okay. This 400 is just a symbolic that area should be larger one. ठीक है, ये 400 बता रहा है that area should be a larger one, but definitely more than 50 hectares we will use empirical formula. There is no issue. So this empirical formula can be used for prediction of storm water runoff for that particular catchment. Some of these formulas are based on local conditions only. Empirical formula मैंने आपको बताया empirically determined हुआ है, experiment के बाद determined हुआ है. तो it might be possible southern India में, peninsular region में, वहाँ का catchment conditions are different. Northeastern states, okay, the 7